Hi, this is going to be a comprehensive and complex lesson, which, once again, will make sense in the future when we apply the results of our work. Now let's get started. What exactly are we going to do? We need to initialize Prisma in our app and add it to the context so we can use it in our tRPC endpoints. Let's get started. Well, we'll need to create a file named ctx in the lib folder, which stands for context. And its content will be as follows. What are we doing? We import the Prisma client from Prisma, create a function createAppContext. In this createAppContext, we initialize Prisma through new Prisma client and return an object containing our Prisma, as well as a function stop, which allows us to stop Prisma. Why do I separate all this? Because technically, in your context, there may be other things that need to be initialized at startup, and there should be a way to stop these processes when you need to. And we also export the context type itself. That is, return type is what this function returns. But since we cannot pass the function itself here, we must pass its type. The type of this function, what it returns, goes into app context. So in app context, we have a Prisma and a stop function. Okay, we created the context file. Now let's initialize this context, meaning let's call the createAppContext function somewhere. For this, go to our index file and do the following. So, before express_app we do context equals createAppContext. What's the situation here? It might happen that we call all this, and everything breaks for us. See? And here we have no error handling. Let's add this error handling. Try catch error. And of course, we will log our error to the console. But what's also important, we need to stop our context. When an error occurs, to do this, you need to call context stop. What is our problem now? Everything inside the curly braces stays inside the curly braces. And that's why these curly braces don't know app context. They say we don't know it. So we do the following. We still declare our variable ctx here and say that it is either app context if we succeed, or we assign it null. That is, initially it's null, but it can become app context. Here we remove the context declaration and only leave assignment. Now we have ctx stop here. But ESLint complains saying we should either catch the error here or send it into void. Okay, the context might be unclear, like broken, so we use a question mark. This means that if there's nothing here, nothing else will be executed. All right, and overall, it looks pretty good here. But I suggest preparing for cases where something that requires a wait might be called here in the future, so that the process still waits for things to complete. But a wait can only be called inside a function declared with async. So let's do the following thing. We will declare a function. So we've declared it, and we'll immediately call it. A very popular pattern too, but at the same time, we're being warned again that items should be either sent to void or caught with catch. But why do we need catch here, when everything is already wrapped in try and catch? So we send it to void, and insert a wait here. Great, good. We've created the context, now we have it. We connect it to Prisma. What's next that we want? We want to use our Prisma context in IDEA endpoints. So, and for that, it would be good to pass this context to our tRPC endpoints. Let's do it. How can we do it? Here is a function for applying tRPC to an Express app. Let's pass the context into it, and now, edit this function. Okay, how do we edit it? It should also accept KTX. But let's agree here, we'll call it the app context, because in the future, it might turn out that besides the app context, we have a separate tRPC context, and we'll talk about their differences later when we implement them. For now, they will be the same, but let's give it a good name right away. So the app context, got it? All right, we've settled on the types. Now how to pass the context into tRPC? It has something like createContext. This should be a function that returns context. And right now it suits us completely. In other lessons, we'll complicate this further. But no worries. Okay, we've passed the app context here. But tRPC doesn't know about app context types yet. But that's how it's set up. Because when we declare our procedures, here in the router, check get ideas, we base it on this tRPC. And this tRPC doesn't yet know anything about the context. Let's inform it as well. You can find all this in the documentation. The advantage of this tutorial is that you don't have to go there unnecessarily. You just take it and do it like this. And if you're interested in digging deeper, you go to the documentation and read why it all works this way and how it's organized. There. So, we define the context type. You need to do it like this. This thing actually just passes types, but doesn't fundamentally do anything right. All set. Types are passed. Good. Let's move on. So, what's next for us? Next, we need to use Prisma in the endpoint itself. So, and what we just did, well, you do it once in your life, and then just copy from projects. But what we're going to do now, that is, using Prisma in an endpoint, is a constant practice. So, good. Well, let's query our ideas from our database. So it was like this, and it will become like this. Const ideas equals. So now where's our context here? Our context is passed here. KTX, here. And we see its type here because we've passed it through. All right, KTX dot Prisma dot. And here the types suggest what models we have. Here's our model ID. We call it and do find many. Here we can also look at what requests are available. We will try almost all the necessary ones during this tutorial. Now we just need to find a set. Find many. But look, if we refer to our schema, what do we see here? We have nick, name, description, and text. But we only need nick, name, and description. If we call it just like this, all ideas with all fields will go into ideas. But we don't need all fields, we only need these specific ones. Okay? But also importantly, this thing returns a promise, so we need to wait for it to complete. Writing await. And await only works inside async. Writing async. Good. And now let's see what we have here. There's such a useful thing as select. Yes. And it lets you specify which fields we need. We need nickname. We need name. We need description. And the standard classic. We still need the ID. The ID is always needed. It will come in handy later. Good. And let's see what we have in ideas. We see that there is an array of these things. All these types were determined because we defined them in the schema and ran the command either pmd or pgc. These two generate the client for us. All right. And now we need to return this object. Return ideas. All right. So now many dependencies are no longer needed. The old code is no longer needed either. Now let's check if it works. All right, backend. Let's restart it. Backend is running, and we didn't touch the front end. So now let's go to the front end and call. All ideas. All ideas. And actually, everything is as it should be. Although you can't tell right away. Let's look in the preview. We got ideas returned with an empty array because we have no ideas in the database yet, but it already works. Let's slowly keep improving our application. An idea will appear, and then we'll see the actual result there. But for now, this is enough. Thank you. Well done, everyone. Thank you. Bye. Let's move on.